Okay, so these are some of the contacts that you can use to contact me in case you have any questions. And as I told you in the group that tonight we're going to be looking at partial fractions. And I think tonight we just do an introduction, and then if we're meeting tomorrow, is it tomorrow or Thursday? Yeah, so when we meet on Thursday, we're going to solve more questions. Tonight, I think I've only gotten 2, if not 3 questions from your tutorial sheet. And then the rest of the questions will come and solve them on Thursday. Yeah, so that other week we start, what's this, matrices. Yeah. Okay, so let's quickly begin. Okay, so I'm going to start first by, actually, before we solve these questions, let me first introduce partial fractions. Yeah, so if you have, for instance, let me write something. Yeah, so I'm sure you guys have seen questions which are maybe in this format. You have something like 3x plus 1 over maybe 2x squared plus 3x plus 1. And then imagine that they tell you to integrate this. They tell you to integrate this. This is just an example. Or let me say I've started with why we learn partial fractions. In short, the question is, why do we learn partial fractions? So if they ask you to integrate this question, just using normal methods of integration would be difficult for you to solve this question. But if you use partial fractions, this is going to be very easy. So what this means is that you have to decompose this into its smaller or simplified fractions. So if you have anything that we call, maybe if you have any function or any rational function that has linear factors, for instance, if you have, let's say on top there, you may have any function like, I'm going to use, let me just use 2x plus 3. Yeah, so this is the one I'm going to use everywhere. So if you have on the numerator, you have something like that, and then the denominator consists of linear factors like ax plus b, and maybe you also have cx plus d. So these are called linear factors because they are linear equations. Yeah, so they are called linear factors because they are linear equations. So let me do this so that at least it's easier for us to solve such a question. So you have something like this. And then you've been taught to decompose this fraction into its partial fractions. So the standard for this one is that for each linear function, we need to introduce a letter, a capital letter. Yeah, that is going to help us to find what we're going to have on the numerator of that linear factor. So for the first one there, we can have a, then we say a divided by ax plus b. Then for the second linear factor, we also do the same. We say plus b over cx plus d. So this is exactly what you are supposed to do when you are dealing with linear factors. Yeah, so we do not only have linear factors. What if the same linear factor is repeating itself? How do you solve such a fraction? I mean, how do you resolve such a function into its partial fractions? For instance, if you have 3 over, then you have ax plus b, then raised to the power, maybe 3. How do you decompose this? So decomposing this is very simple. So first of all, you write your a there, and then you say over this same linear factor, and you're going to have ax plus b. And then from there, you're going to say b over the same linear factor is going to be written down here, ax, then plus b. Then we are going to square this. So after squaring this, so after squaring this, we also introduce, also add another one, which is going to have the power 3. So we're going to have plus c over ax plus b, then raised to the power 3. So this is how you you decompose it. So this is just what I'm giving you are just standards. We're going to look at how we can apply these in solving questions. Yeah, so we have another one. What if you have a quadratic equation as the denominator there? You have a quadratic factor. How do you deal with that? So we have something like this. Then down here, you have, yeah, so down here, you may have maybe something like, okay, let me put x on top. Then down there, you may have something like, maybe you have x squared plus b. So this is a quadratic equation that cannot be factorized. Yeah, so if you have a quadratic equation that can be factorized, something like this, if you have anything in this format and it's factorizable, then the first thing that you need to do is to factorize this. So the first thing that you need to do is to factorize the denominator there so that you have linear factors there. Yeah, so you know that whenever you factorize a quadratic equation, the solutions are usually linear factors. Okay, so there's one who's trying to write on the board. Please stop that. There's somebody who's trying to write on the board. Please stop that. Okay, so this is how you are supposed to do that. So when you have a quadratic equation that you can factorize, you have to factorize it, and then you write the standards according to the factors that you have there. Then what if the quadratic equation cannot be factorized? How do you deal with that equation? So it's very simple. So if you have something like this, you have a denominator that can't be factorized, something like this. This can be factorized. So now, how do you deal with such an expression? So this is very simple. So what you're going to do is, for this part, which can be factorized, we're going to say ax plus b, and then everything over this same expression that we have there. So you have ax squared plus b. And then if you have, let's say for instance, you have another x this side, you have x outside there. So what do you do with that x? Or let's say x minus 1. Let me write it properly so that we don't confuse some people here. You have something like this. How do you deal with this other part? So you just add a plus. Since this one is a linear factor, you just add a c, everything over that same linear factor. So this is how you deal with partial fractions. But there's also another situation where, for instance, what you've been given, okay, so let me make this clear to everyone. So these, I mean, what I've explained here, yeah, so what I've explained here is, only applicable when the power, or rather when the degree of the numerator is less than the degree of the denominator. So when you check the degree of the numerator for this first one, is 0. For this one, it's also, the degree is 0. And then the denominator here, because we have x times x there, the degree of this denominator is what? Is 2. Because we have the power 3 on the second one here, the degree of the denominator is what? 3. So what I've told you here is only applicable when the degree of the numerator is less than the degree of the denominator. So in other words, if you can't understand the word degree, we're simply just talking about the power, the highest power. So if the highest power on the numerator is less than the highest power on the denominator, you are supposed to use this. But what if the power of the numerator is greater than the power of the denominator? What do you do with such a situation? So that is also simple and straightforward. So if the degree of the numerator is is, okay, let me just use numbers there. So you have something like this. And then we're dividing everything by, let's say you have x squared plus 1. So if you have something like this and they tell you to decompose this into a partial fraction, so this is a very simple question. How do you deal with that? So what you just need to do is to use what we call long division. You divide this into that. So when you divide this into that, you are going to get the answer, which we call the quotient. So I'll say that this quotient to be a function of x, of course. So this is going to be q of x plus the remainder that you are going to get there will be remainder, and it may also be the function of x. Sometimes it can be a constant, then over this same denominator there. So let me make it like this so that at least it helps us to understand. We have something like that. So we have x squared and then minus 1. So now after dividing this into that, well, let's say for instance, if you use long division, So if you have forgotten how to use long division, you can contact me, you can tell me after this lesson to send you a video where I explained how to divide functions using long division so that you can have a revision, can have a quick recap even before you meet this question on the exam. So when you divide this into that, you're going to get the solution there, which we're calling the quotient, which is the q of x. Then after doing all your mathematics there, you discover that you're going to have something this side as the remainder. So I call this r of x. So this is what you put as the numerator there. And then the denominator is simply just this same denominator there. But when you look at this denominator here can also be factorized. So if you can factorize this denominator, what you simply just have to do is you factorize. Yeah, so let's see how we can factorize that. So after factorizing the denominator, this is the difference of two squares. If you check, we have x squared minus 1. So this can also be written as x squared minus 1 squared, which can be written as a difference of two squares as x plus 1 and x minus 1. So where there is this part, we can put x plus 1 and x minus 1. So we'll have something like this. We have x plus 1 and x minus 1. So now after having this, so after writing that, this makes our work easier now. So from there, we know to say our first function will be the quotient there, and then our first function will be the quotient, and then we say plus the remainder there, or let me not write this. Let me say we resolve this expression there into its partial fractions. So how do we resolve that? We have the first linear factor there and the second linear factor. So we say a over x plus 1, then plus b over x minus 1. And then you continue with the process that I'm going to show you immediately after this. Okay, let's take a look at some questions now. We see how we're going to apply these same methods that I've shown you. Okay, so we look at the questions. So this is the first question that we have. So the first question we have is 7x minus 44, then everything over 4x squared plus 25. So we're dealing with bigger numbers and I don't have a calculator anywhere nearby with me. So make sure that you pay attention to the process. So I may or not make some errors when finding the answers. Yeah, because I don't have a calculator here anywhere nearby with me. So the first thing that we do, we see if the quadratic equation here can be factorized. So how do you know that this can be factorized or not? So how do you know? You can try to find the factors. So the first thing, we find the product. So the product is what? 4 times 21, which is 84. And then the sum is simply just what we have there, which is 25. So do we have any two numbers that we can multiply to give us 84? Then when we add those two numbers, they will give us 25. The same two numbers, 4 and 21, isn't it? Yes. So we proceed. Let's factorize that. So if it's factorizable, you go on to factorize the quadratic equation. So let us factorize this quadratic equation. So we have 4x squared plus 25. Is it a minus there? Yes. We have a minus there. Let me put x there. Then we have a minus 21. So we factorize this. So we said our product is what? Our product is negative 84. Then our sum is 25. So any two numbers that we can multiply to get negative 84, 21 and negative 21. But can we add them to get 25? So this is not adding up, isn't it? Or maybe perhaps someone knows. You can simply just tell us to say, okay, there are these numbers that we can add to get 25, and then when we multiply them, we're getting 84. Do we have any numbers? Okay, so if we can factorize this, then if we can factorize this, like I said, I don't have any calculator nearby, so we assume it can't be factorized. But if you can factorize this, then we have to, but I don't know why I feel this question can be factorized. Do you have, okay, let's try to do this. I think this will even be the best time to show you how to find the factors properly, in case you have challenges. So we get the product. The product is what? Is 84, is negative 84. So which two numbers can we multiply to get 84? So we know to say 2 times 40 what? Negative 2 times 42 will give us what? 84. Then we have 2 times negative 42. Then we have, can 3 go into 84? Yes. So 3 times, so 3 into 8 there. So we say 3 times 3 into 8. The answer is what? 3 into 24. The answer is 8. So we put a negative somewhere there. Then we can also have 3 times negative 28. So now when we add the first two here, what are we going to get? So when you add these two numbers, what are we going to get? We're getting 40. When we add these two numbers, we're getting what? Negative 40. When we add these two numbers here, we're getting 25. When we add these two numbers here, we're getting negative 25. So we get the one, we get the group of numbers that are giving us 25. And in this case, it's what? Negative 3 and 28. So we can factorize that. Okay. So we can factorize that using the factors which we have found to be negative 3 and 28. So we have 4x squared plus 25x minus 21. And then we have 4x squared. So we say minus 3x plus 28x minus 21. So find a common factor there. We have x, then we have 4x there, minus 3. And then there, what is common is 7. 7 is common there. So we say plus 7, open brackets. So 7 into 28, we're getting 4. Then we have x there, this x. Then minus 7 into 21, we have 3. Yeah, so this can be factorized. So we have 4x minus 3. And then we have x plus 7. Okay, so these are the two factors. So this expression can also be written as 7x minus 44, everything over what? 4x minus 3, then open brackets x plus 7. So this is what we have as our factors. So we can now decompose that because it's now easy. So let's go through the process step by step. So I'm going to write this expression. I'm going to write it, okay, let me not write it this side. I'll put it this side. So we have 7x minus 44, everything over. We have 4x minus 3. So we have two linear factors here. And remember what I said, if you have two or more linear factors, you simply just say the first factor there, you associate it with a. So you say a over 4x minus 3. And then you say plus b over x plus 7. So what you do here is you find the common denominator. Yeah, so you're going to find the common denominator, and that is going to be, yeah, so this is going to be 7x minus 44 over 4x minus 3, and then open brackets x plus 7. And then this is going to be equal to, so this side we find the common denominator, and the common denominator this side will simply just get what you have this side. Yeah, so I don't like complicating things. So you just get what you have this side as the denominator. Then you write it here. So you have 4x minus 3, then x plus 7 there. And then on top there, you say this divided by that, you're going to get this part. And then this part times a means that you're going to have a, open brackets, a plus x plus 7. And then from there, you say this into that expression means that you're going to get this part. So this part times b, you're going to have a positive there and then a b times that. So, okay, me, to be honest with you guys, I don't like complicating things or to make things as if they're difficult. So what I just do, or what you should simply be doing if you don't want to be getting confused, the common denominator should just be the product of what you have there, or you just get what you have this side. Then, and then to get what is on top there, you simply just multiply this a times what you have down there. So a times this side, and then this times that. This is what you're going to get on top. Yeah, so that is the easiest way you do that. If you don't want to be getting confused. Okay. So let's quickly finish up this question. So after doing this, you can see that mathematically you can cancel this and that because they are the same. Then you're just going to remain with 7x minus 44, and this will be equal to a times x plus 7, then plus b 4x minus 3. So from there, let us just finish up this question. Yeah, so we'll only do one question tonight, then we'll come and do the remaining questions in the next session. Yeah, so today I just wanted to introduce you to partial fractions, and then next time that's when I wanted us to solve all the questions at once. So this part that you are seeing here, so what you can do is you look at the factors that you have here. So is there a way that we can make this first term here to be a 0, or this second term to be a 0? So if you want to make the first term to be a 0, you're going to say let x be equal to -7. So that if I put -7 while there's x there and I add it to that 7, this will give me a 0. 0 times a, it will be 0, so that I'll just remain with this part alone. So I'm going to put -7 while there's x in all this expression. So I'm going to have this. So don't worry if you have questions. The session is being recorded and I'll send it to the group. You all have access to it. So we have a, open brackets. So when you put -7 there, we write, so I'm just replacing -7 wherever there's x in the whole expression. So we have B there, and open brackets 4, -7, then -3. So 7 times -7 there, we're getting -49, then -44. Then we say this is equal to, so -7 and 7 will give us a 0. 0 times A, this will be a 0 there. Then here we have -7 times 4, this will be -28. Then -3 there, so we have -3 there. So when you add, these two numbers this side, you are going to get okay, so this side, when you add what you have this side, you have -28 and -3 there, you're getting -31. And then this other side, you have 44. When you add 44 and 49, you have, okay, for the sake of those that don't know how to add big numbers, let's do it together. So 9 plus 4, you're getting 13. So you have 3 there, plus remainder 1, 4 plus 4, 8, 9 there. So we have 93 this side. So we're going to have -93. Yeah, so, sorry, this part here is supposed to be multiplied with B because we have B there. Yeah, so B times that. So I forgot to write that, sorry. So I have 0 plus, we have a B there. So we divide by -31, divide by -31. So this is what you're going to have. So when you divide this and that, you remain with B this side. Or for the sake of understanding, let me write it where it is. So we have B this side. Then when you divide -31 into -93, you're getting 3. So the value of B becomes what? 3. So now the other thing we need to do is to find the value of A. So how do you find the value of A? We also find, also use that same expression that we have, which was 7x minus 44 is equal to A, open brackets, x plus 7, then we have plus B, open brackets, then we have 4x minus 3. So the other thing here that is needed now is for us to find the value of B. So how do we find the value of B? So we find a number again that, or we can compare the coefficients. So there are two ways. If you want, you can find the number that will make this, this expression to be a 0. I mean, we're trying to find the value of A, not B. So we have to make this part a 0. So do we have a number that we can put at X and make it a 0? So if you don't want to use that way, or if you think that is difficult for you, what you just need to do is to compare the coefficients. So this side, I'm going to get the constants, or I can get the coefficients of X. So if I get the coefficient of X this side, I'm going to get 7. Then on the other side, okay, so when this link ends, should join using the same link so that we just finish up this question, then we call it a day. So this side you have 7. And then on the other side, you have, first we start with this part here, A times 7 there.